You remember in the first lecture, we talked about the turning the messy form of equation into the standard form. What was the standard form of circle? You remember it was x minus a whole square plus y minus b whole square equals r square, radius square. What is a and b? A comma b. A comma b are the coordinates of the center of the circle. This is center. This is my circle. So a comma b is the central coordinate. Point O having coordinate a comma b. What is r? R was the radius of this circle, the line joining the center and the boundary, circumference we call it, of the circle. So the distance from P to O, it is radius represented by r. It is the length. It was like, okay, the standard form was like a address of a territory. The territory is like a shape. Every shape has an equation. I told you. Mathematically, why do we need an equation? So in mathematics, we have to write things. So how will you express the visuals in your writing in textual form? Equation are there. Equation are the substitute for your visuals. Every shape has an equation. For example, a line. A line also has an equation y equals mx plus c, if you remember. A curve like this, a U-shaped curve, has an equation of this: ax square plus bx plus c equals pi. In the same way, circle has this equation. Anyways, what I'm saying is, you remember the wise man from the old town? So before he left, he created a town, the city he built, and the city was of circular shape, like this. And this was the whole kingdom. This was the island of rectangular shape, for example. So you see, for the people of the island, of the town, there are only three territories, 3 points of existence. People reside, some people were residing outside the territory, the circular territory, the wise man designed outside somewhere here. Some people were residing on the boundary, the guards of the town, and the citizens were residing inside it. There are 3 points where, okay, there are 3 possibilities where the people were residing. There are 3 possibilities of existence. In the same way, that's related to the mathematics. So these are the 3 points. Point number 1, point number 2, point number 3. They will give you a random point, like 1, 2. They will give you the equation of the circle. For example, x minus 1 whole square plus y plus 2 whole square equals 25. That is the equation of the circle. They have given you a point. Now they are asking you, for this given circle, this equation represents a circle. For this given circle, where does 1, 2 point lies? Outside, on the boundary, or inside? This is our present lecture. How you will calculate about this. So first of all, what we will need is a equation first, which will be given in the question. And what is the equation? Equation is, standard form of equation is x minus a whole square plus y minus b whole square equals r square. That's it. What is r? R is the radius, the line joining the center to the boundary. What is x comma y? From the equation itself, x comma y are any arbitrary point, any random points on the boundary. Make sure that, or any point. There are 3 possibilities of existence, so it can be anywhere. X comma y is your hypothetical point, like I assumed in the example 1, 2. It can be anywhere. Okay, and what is a comma b? A comma b is the center of the circle. Center of the circle. So let's find out how you will calculate, how you will know that your point lies on the boundary. What is a point? A point is, for example, a point represents a citizen of the town. 1 comma 2. So 1 comma 2 is a citizen, a person. So 1 comma 2 will be found outside the town, will be found on the boundary of the town guarding the fences, or will be found inside the territory. How you will calculate that? So the wise man give you the way also. He will tell you. You just have to substitute the point and compare to r square. It's very easy. One of the easiest thing in this topic. For example, in the question they will give you the equation. What kind of question it is? They are asking you, where does my point lies? The point x comma y, where is it? On the boundary, inside or outside? What they will give you in the equation, in the question, they will give you equation of circle. For example, I am taking a hypothetical equation like this: x minus a whole square plus y plus 2 whole square equals 25. Equation is now given to us. Okay, and they have given a point also, 7 comma 1. They are asking us, where does it this point lies? Because this equation represents a circle. This is a circle in mathematical form. So where does this point lies? Outside, on the circle, that means on the boundary. Okay, I will not say on the boundary, I'll say circle. Circle is the boundary itself. On the circle or inside the circle. How will you calculate this? You just have to substitute. What is this 7 comma 1? It is your arbitrary point x comma y. Any random point in the equation. Put that value in the equation. 7 comma 1. When you will do it, so you shall get 7 minus, in the place of x, 7 minus 3 whole square. Okay, why not 1? Why x equals 7? Because the first value always tells the x, second value tells the value of y. So first is 7, so x value is 7, plus second value is y, which is 1. 1 plus 2 whole square equals 25. Let's do it. And when you will do it, you will see that your LHS will become, see, 7 minus 3, 4. 4 square is 16. 16 plus 3 square, which is 9. 16 plus 9, 25. See, your LHS is equal to RHS. That means it exactly equals to your R square. What is 25? 25 was the radius square. It is getting to equal that. If this happens, if they are equal, condition 1 it was, if they are equal, if your LHS equals RHS, what is RHS? RHS is the R square, radius square. If this is equal to radius square, then the point 7 comma 1 lies on the circle itself, on the boundary, on the fences. You will write, hence 7 comma 1 lies on the circle, not inside, not outside, but exactly on the circle. All right, let's see other possibility. So I'm for the same equation, the equation is same, x minus 3 whole square plus y plus 2 whole square plus 25. Okay, this is the equation we are taking for all the 3 cases, common equation. Let's change the point. Now the point is 4 comma 0, and check where does the 4 comma 0 lies for this circle. Equation represents a circle. I'm again saying equation represent a circle. This equation itself is a circle. Imagine this way. Okay, now the new point is 4 comma 0. Let's check where does this new point lies. New point is 4 comma 0. Equation is the old one, x minus 3 whole square plus y plus 2 whole square equals 25. Check it out. Put x equals 4, y equals 0. So 4 minus 3 whole square plus 0 plus 2 whole square equals 25. And when you will do it, it is coming out to be 1 square plus 2 square, 5. 2 square is 4, 4 plus 1 is 5. 5 is less than 25. It is not equal. That means what is 25? 25 was the R square, radius square. So if your RHS, if your LHS left hand side things come less than your R square, that means whatever value was written on the right hand side, 25, which represent the radius square. If it is coming less than that, so lesser than means it is somewhere inside, near the territory. So 4 comma 0 lies inside. Okay, so if condition comes like this, then the point lies inside. condition is like this, your LHS comes out to be less than R square, which is 25. Then point lies 4,0 lies inside. Okay, we are very clear about this now. What else can be the condition? For the same equation, I'm taking any other point and check it out where does it lies. 10,0, and it is obvious that this point should lies outside since we are taking all three examples. It will lie outside. For outside, what will be the condition? For outside, your LHS will be greater than R square. Let's check it out for the same equation. The same equation was x minus 3 whole square. That means 10 minus 3 whole square plus y plus 2 whole square. Y value is also 10, so 10 plus 2 whole square equals 25. Let's check it out if it is really equal to 25 or less than or greater than 25. So when you will do it, 10 minus 3 is 7. 7 square is 49 plus 10 plus 2, 12 square is 144, and this value is obviously greater than 25. And this is happening. When this is happening, your LHS is this time greater than your R square, because 25 represent radius square. So when your LHS is greater than R square, this is your third condition. Always your point 10, 10 lies outside. So we have seen all the three conditions. If you are giving in a question, let me conclude this. Equation will be given in the question. X minus a whole square plus y minus b whole square equals radius square. This thing will be given in the question. Any random point x comma y will be given. You just have to put the value of x comma y in the given equation. Condition number 1. If your LHS coming out to be equal to RHS, then the point lies on circle. Second point, if your LHS is coming out to be less than your RHS, lesser than means inside the circle. Third condition was when your LHS left hand side calculation was coming out to be greater than, like this. In the earlier example, it was greater than RHS 25. Then the point lies outside. Okay, this was the thing. Just remember this law. Okay, this was the only important thing. This one. Equation will be given, point will be given. We have to check where does the point lies, inside, outside, or on the circle. So we are able to check it out by ourselves now. Next thing is where a line meets circle. Okay. Part number 5. You can say type 5 of questions where a line intersects a circle. So this was the circle. Circle will be given, that means equation will be given to you in the question. A line will be given to you, that means the equation of line will also be given in the question. Like this. They will ask you where does this line is cutting the circle. So there are three possibilities. Okay, the line can be outside the circle, like this. Okay, the line can be inside, but a line, okay, what is a line? A line is extendable on both sides. It is infinitely long. So it is possible that line is infinitely long and even not touching the circle at a single point. It is far away from the circle. It will never touch. This is our first condition. A line can just touch the circle from outside at only one point, like this. Such a line is known as tangent. It only touches the circle at one point. See, it is touching the circle at only one point. The point is P. I'm calling it P. Hypothetically. Third condition can be the line is cutting the circle at 2 points. This one, from inside. What are these 2 points? See, I'm calling this point as A point and B point. 3 lines we are having here. One of the line lies outside. Second line touches at single point from outside. Third line is inside, intersecting at 2 points. Okay, the first line Does not have a special name, it's a line only. But such a line which cuts a circle, which meets a circle, which meets a circle at a single point, at a single point, is tangent. Tangent. This line is known as tangent. A special name for this line. What is the characteristic? What are the properties of tangent? The tangent will only meet the circle at a single point. This is our tangent. Okay, and what is this AB line? Third condition, third possibility. This is chord. The special name of this line is chord. CHORD. We call it chord. A chord is a line. The special name of this line is chord. It only meets circle at 2 points. This is our chord. Now the question is, where a line intersects a circle? How will they form a question on this? They will give you a circle, first of all. Giving a circle means they will give you an equation of circle. Okay. The question is, where does the line intersects? Intersect means cuts the circle, meet the circle. What can be the given condition in the question? They will give you a circle, that means equation of a circle. This will be given to us. Ax square, not ax square, will be x minus a whole square plus y minus b whole square equals radius square. This equation itself is a circle. Circle will be given to you. What is circle? A center a comma b and the radius r. This is circle. It is given to you in the equation. A line will be given. When I say line will be given, that means equation of a line will be given. Equation of a line will be given. What is the equation? Y equals mx plus c. When I say y equals mx plus c, it itself is a line. The slope is given. The y-intercept is given. So a circle is given, a line is given. Then what? They will ask you where this line, this particular line is cutting the circle or touching the circle and not even touching the circle. How will you check this? Okay, let me give you an example on that. So equation of circle is given. Equation of circle is x square plus y square equals 25. Okay, and the line equation is y equals x plus 1. This is given. They are asking you what are the points of intersection, where does it intersect, meets. The way of doing it is substitute the value. See, in the equations of the line, y value is given. Just put the y value here in the circle's equation when you will do it. X square as it is plus y value, y square. Y's value is x plus 1. So x plus 1 is y only. Check it out. X plus 1 is y only. And here then y square. So do the square of x plus 1 equals 25. Okay, then what? Let's solve it. X square plus, now it's a square, x plus 1 whole square. Let's open it up using the a plus b whole square identity. A square, so x square plus 1 plus 2x. This is how we open it up. Just open the whole square of a plus b equals 25. Then what? Okay, let's arrange the quadratic equation and you shall get 2x square plus 2x, and then this will be coming to this side, minus 24 equals 0. Let's reduce this, let's simplify this. You will take 2 common and it will become, and 2 will go to the other side, so 0.2 is 0 only, and you will get x square plus x minus 12 equals 0. We got a quadratic equation. Can you factorize it? It's very easy. The factors of it will be x plus 4 and x minus 3. This is why I am saying all the previous chapters were our foundation. We are using the same principles. Okay. The x value, when you will compare each bracket to 0, your x value comes out to be minus 4. Your x value comes out to be plus 3. Can we calculate the y also? So the y was equal to x plus 1 in the question, if you remember. It was given to us. See, it is given right here. Y equals x plus 1. We know the value of x. We have two values of x, and hence we will get two values of y also. So y equals x plus 1. X is minus 4 plus 1. We will get minus 3. What is your point? One of the point is minus 4 comma minus 3. Minus 4 comma minus 3. Second point, x equals plus 3. So y equals x plus 1. 3 plus 1 is 4. Another of your point is 3 comma 4. We got 2 points. That means these are the points where the line exactly intersect the circle. If I show you, if this is your circle for the given equation, okay, and this was your line, then your line is cutting exactly at these 2 points. This is my line. So these are your points. This point is minus 4 comma 3 maybe. This can be 3 comma 4. We have found this. This is our solution for the question where it was asking where does this line cut the circle. So we have done this exactly same. What was the way? What we really did was we just substituted the line equation into the circle's equation. Circle's equation was x square plus y square is equals 25 this time. We just substituted the value of y in the equation. When we did, we got a single quadratic equation in the last. Factorize the quadratic equation. When we did, we solved the value of x, which is minus 4 and plus 3. For each value of x, we got values of y also by using the x value in the equation of line which was given to us. Then we got the value of y also. Then value of x comma value of y, that makes a coordinate. We got the coordinate. Coordinate represent a point. We got the point. We got the value of x first from the quadratic equation. Then we got the value of y also by putting the x value in the given equation, given line equation. So we got x comma y point, which is a coordinate. Coordinate is a point. We got second point. This means the given line cuts a circle at 2 points. What line it is? Is it tangent, chord, or normal line? It's a chord. Okay. They can also form a question like this. Tell us if the line is chord, tangent, or normal line. This is the way we'll tell them. If we are getting two values, that means the line is intersecting the circle, meeting the circle at 2 points. Hence, it should be chord. If you are only getting one value of x comma y, only 1 point, it should be a tangent, because tangent is a line which only meets at 1 point. If you are getting no value of x comma y, that means your line somewhere lies outside. It is not even touching the circle, because when your circle and line touch, only then you get a value of x comma y. Your line touch at 2 points, you got two values of x comma y. Your line touch at 1 point, you will get only one value. If your line lies outside, not touching anywhere, you will get no value of x comma y. This is also a way of finding out. If you get no value, the line lies outside. If you get only one value of x comma y in the last, that means the line is a tangent. And in this example, the line was touching at 2 points and it is a chord. Okay, this was one way. And if you remember, we don't even have to solve this. For example, if the question is not asking us where does the line meet the circle, this is not the question. The question is not asking us to find the points. The question is only asking us what this particular line is, a chord, a tangent, or a line lying outside. How will you calculate them? You can escape all this calculation since you don't have to calculate the points. This is not the question. The question is not asking you the points. It's only asking you chord, tangent, or a line. Designate it a name. How will you do it this particular thing? You only have to do till the quadratic part, like this. And once you did the quadratic equation, you remember how to find determinants. So the quadratic part was x square plus x minus 12 equals 0. You only have to do this particular thing. You don't have to solve it. You don't have to factorize it. Stop it there, because we only factorize when we need to find the points. But the question is not asking us the points of intersection. It's only asking us about the nature of line, chord, tangent, or a line. Then you don't have to find or factorize this particular quadratic equation. What you will do next to it, you will have to find the determinant of the quadratic equation. Determinant. If you remember, determinant is basically b square minus 4ac. Okay, you can find the value of b, a, and c. How will you do it? So compare the quadratic equation with the standard quadratic equation, ax square plus bx plus c. When you will do it, your a value is 1, since a is the coefficient of x square, 1 is the coefficient of x square. B is also 1, since b is the coefficient of x, and here the coefficient of x is 1 also, so 1. C is minus 12. You got all these values, put that in the determinant formula, v square minus 4ac. When you will do it, your d value will tell you about the nature of line. You will escape the calculation that we did in the earlier question. So there are three possibilities of d. D can come positive. If your d value is positive, it can be anything, 1, 12, 13, 100, 1000, anything. It should be positive. If your d value comes out to be positive, then then it will cut at 2 points. Your line will meet at 2 points. At 2 points, line is a chord. Second possibility of determinant is d value is negative. If d value is negative, that means no solution. If you remember in the quadratic, if determinant value comes negative, no solution. If determinant value comes positive, 2 solution. Solution means 2 points. If d value is negative, no solution. That means no point of intersection. Line is not even cutting. Line lies outside. So line lies outside. Third possibility is line is a tangent. So only one solution, only one point of contact. D equals 0. If your d value comes out to be exactly 0, d means b square minus 4ac. How you will get b square minus 4ac value? By from the given equation, from the equation you solved, the quadratic one. When you combine the linear and the circles equation, you got this one. Okay, so d value comes out to be negative. That means only 1 point. And when 1 point is there, that means line is a tangent, because tangent is the only line which meets circle at 1 point. Okay, so we have seen how to find the nature of the line also, without even factorizing the quadratic equation, without even finding the point of contacts. Point of contacts, that means where does the line meet a contact with the circle. So at 2 points, that means it's a chord, like this. At 2 points, that means it's a chord. At only 1 point, that means it's a tangent. At only 1 point, this is 1 point. And it is anywhere far away, like this. That means no solution. Determinant value is negative. And if they're asking you to find the point of contact, for that also you know the way. What is the way? You will combine the circles equation and the line equation, and you will form a single quadratic equation. Solve the quadratic equation, you get the value of x. From the value of x, you can get the value of y also from the lines equation. You will get 2 points. It will be a chord. You will get 1 point. It's a tangent. You will get no point. So line is outside the circle. That's it. Okay. Let's talk about tangents in detail. It's quite an important thing. Tangents, because it will be continued in your further syllabus also. In other chapters, we will see it will be there. So now we are having tangents. Let's see about them in detail. There is a very genuine fact the wise man told you in the previous lecture about the tangents. He draw a circle, if you remember, by his footsteps. And he took a stick and he dropped his stick anywhere outside, touching the circle at only 1 point, like here. And then the wise man stand exactly at the point of contact. This is the point of contact. This is where he's standing. You remember, he had a rope tied in one of his leg. The dead dash line is a rope, and the other end of the rope was tied on a nail. This was our nail. Okay. Nail is a center. So Wiseman told us that if I stand, okay, the rope and my line, the stick that I have dropped in such a way, okay, dropping the stick is also a condition. You have to drop the stick in such a way that it should be a tangent. That means it should make only one point of contact with the circle. And exactly at this point, he stands like this. Then the rope tied makes a 90-degree angle with the stick. The rope makes a 90-degree angle with the stick. So the villagers was not curious. He said, okay, what's so miraculous about this? Then he told that, okay, I'm gonna change my position. He took another stick. And now this time he dropped it here. Like this. The black stick is the second stick. Only one point of contact. That is the condition. It should be a tangent. Then the wise man standing here. Right here. With the rope tied in one of his one end of the rope is tied on his leg, another end is tied on the nail. So it should be like this. This time also the rope makes a 90-degree angle. This time the villagers found it miraculous. Though it was not a magic, it was mathematics. Okay, so a tangent will, okay, what is this rope? Isn't it the radius always? The line, what is radius? The length from the circle to the center. Here also, from the center to the circle. So the rope is the radius every time. So radius makes a 90-degree angle with the tangent always. Always. Okay, so property of circle. That means from now onwards, you can also say tangents we know already. Tangents is a point which only has a one point of contact. Nothing new about tangents. But now I'm telling you a property of tangent. What is the property of tangent? The property of tangent is tangent T. Okay, I'm representing tangents with T. So tangent will always be perpendicular with the radius. Okay, what is perpendicular? First of all, perpendicular means makes a 90-degree angle. Perpendicular. It's a synonym for 90-degree angle. Right angle. Right angle, you call it 90-degree angle. You call it perpendicular. You call it right angle. Right angle. They are all same. What is the symbol of perpendicular? This is a symbol of perpendicular. Okay, I don't want to write the whole spelling perpendicular, so I just draw the symbol. A inverted T. That's a symbol of perpendicular. Okay, from now onwards, I won't write angle. So the symbol of angle is this. This is a symbol of angle. A lazy L who's just about to sleep. Okay, so angle is represented by this. If you ever see me writing this, so it will infer for angle. Okay, since we're talking about symbols, so if a line is parallel, so this is the symbol of parallel lines. I will not write the spelling parallel. What is parallel? Your railway tracks are parallel always. Parallel means the distances between two lines will always be same. They will never diverge or converge. See, these are diverging line. They are opening their mouth. These are converging line. Okay, see, like this. They are meeting together. But a parallel line is something which is neither diverging nor converging. Always equal distance. So railway tracks are converging, not converging, parallel. This is the symbol of parallel lines. Two small lines, parallel. Anyways, we're not talking about parallel lines. I was telling you that a radius will always be perpendicular to your tangent. That's it. That single fact turns every tangent question into your perpendicular gradient rule. If you remember, the single fact, the single property of tangents, tangent will always be perpendicular to radius. That makes a kind of question. Again, you will realize that somehow everything is related. If you remember, in the coordinate geometry I told you, oh, tangent is a line, no doubt. Radius is also a line, no doubt. A line is the equation, y equals m1x plus c. Okay, the radius is also a line, so it should also have an equation, y equals m2x plus c. I'm calling it c1 and c2. Okay. So these are two equations, two different equations. If you remember, what is m1 and m2? m1 and m2 are the slopes. So if you recall, if two lines are perpendicular, then the product of their slopes has to be -1. If you remember, so m1 times m2 has to be -1. All right, I'll say it again. Tangent is a line, radius is a line, and it's a law. It's a universal law that they have to be perpendicular always, makes a 90-degree angle. And since these are the lines, they are perpendicular also, then their slopes product will always be -1. That's also a law. So it will be true for this also, since they are perpendicular. For any two perpendicular lines, the product of their slopes will be -1. The product of their gradients will be -1. For any two lines who are parallel, if you remember, parallel or anti-parallel, like this, parallel. These lines are parallel. Their slope is m1 and m2. Their slopes has to be equal every time. But if two lines are there, like this, and they're perpendicular, m1 is first line, m2 is second line slope. So the product of their slope will always be -1. m1 times m2 is -1 always. This is what I'm saying. m1 was one line slope, like m2 was the slope of second line. In the same way, you are having tangent and radius, two lines perpendicular also. That means their slope product will also be -1. Clear? That means if the slope of tangent is m1, if the slope of radius is m2, that means m1 times m2 always equals -1. Remember it like a formula. Okay. So tangent slope, radius slope will always multiply and give you -1. That's the logic. And how will they form a question on this? See, they will say find the tangent to a circle with a center. So they will give you a center of the circle. Center of the circle. Center of the circle is given, which is 2, 3. And the point of contact of the tangent. Point of contact. The point where the tangents meets the circle is also given. Point is 5, 7. They are asking you find tangent. Find tangent means find tangent's equation. Tangent is a line, so find the tangent line equation. Tangent equation. You are given the center of the circle. You are given the point of contact of the circle. You have to find the equation of tangent. First of all, what we will do is, for writing the tangent equation, what do you require first? So a tangent is a line, and every line's equation is of this standard form, y equals mx plus c, right? But this time, this m is the slope of tangent. I am calling it mt. So mt is just a representation. Okay, so m is the slope of this tangent. Mt is the slope of this tangent. You have to, once you get the value of mt, once you get the value of c, you will get the equation of tangent. Because in the equation y and x remain same, you only have to put the value of slope and intercept c. So let's calculate this mt and c. We'll plug in the equation and that will become the tangent. For finding the tangent, there is no possible way in this question, but we can find the, see, I'll help you imagine this question now. The question says for a circle is not given. That means circle's equation is not given, but the center of circle is given, which is 2, 3. It is given, center of circle. I'm calling it O point. Okay. And the point of contact of tangent is given. So where the tangent meets, this point is given. This point is 5 comma 7. They are asking you find the tangent. That means find the equation of this tangent. I'm drawing the tangent. You have to find the equation of this blue line. Okay, and this is the equation of blue line. Y equals mtx plus c. But how will you calculate the value of mt? That means slope of m of tangent or intercept. For doing this, we know something. We cannot find mt, slope of tangent, but we can find the slope of radius. And I'm drawing the radius from point of contact to the center. This is my radius. Do we know formula when two coordinates are given? The ending one, because this is the starting point of radius, this is the ending point of radius. So when the starting and ending point of a line which is radius is given, can we find the slope of radius? Slope of radius, I am calling it mr. Slope of radius. And the formula is y2 minus y1 over x2 minus x1. This is why I am saying keep revising the previous chapters. It was in coordinate geometry. Okay. If you need the notes again, just ask me. y2 minus y1 over x2 minus x1. So y2 value is, so this is my final point. So 7 minus 3. And then x2 minus x1. So 5 minus 2. And this becomes 4 upon 3. 4 upon 3 is the slope of radius. And do you remember a formula? That means I told you previously that the product of the slope of tangent and the radius always makes minus 1. See, minus 1. The product of the slope of tangent times the slope of radius always gives minus 1. We can use it here to find the slope of tangent. We just found the radius, mr value. Mr value is 4 upon 3. So mr times mt will give you minus 1. What do we know? We know mr. We just have calculated mr. 4 upon 3. Let's put it mr 4 upon 3. 4 upon 3 times mt will give you minus 1. And hence we can find the value of mt. When you will find the value of mt, mt will be equal to minus 3 upon 4. See, 3 is in division, so it will go in multiplication. Minus 1 times 3 is minus 3. 4 is in multiplication, so 4 will go in division. So minus 3 over 4. We got the value of tangent of slope. Okay. So we got this thing. Okay, we got the mt value, which is minus 3 over 4. What is missing? C is missing, intercept. This we cannot find, so we will use this other form of equation. Okay, in such kind of question you will not use a slope intercept form. This thing is known as slope intercept form. We will use the point slope form. This equation rather, y minus y1 equals m times x minus x1. We will use this equation. So in this equation we got the value of mt. Mt is minus 3 upon 2. What is missing? x1 comma y1, and we know it already, it was given in the question. See, point of contact, this x1 comma y1 has to be the point shared by the tangent also. It is any point lying on the tangent, and we know the point, it is 5 comma 7. 5 comma 7 lies on tangent also. Just put it in the equation and you will get the final equation. The equation of tangent, that I am using is y minus y1 equals m times x minus x1, and y minus y1. So what is the value of y1? The point were 5 comma 7, point of contact. So 7 equals slopes mt is minus 3 over 4. Okay, x minus x1, so x minus x1, x1 value is 5. This is the equation of tangent. You can also simplify it further, but you can leave your answer here. It's not incorrect. Okay, you can leave your answer at this step also, or you can solve it. It makes no difference. So I'll solve it for you. It will become y minus, okay, this 4 will be coming to this side. So 4y minus 4 times of 7, 28 equals minus 3x plus 15. And when you will solve it further, it will be 3x plus 4y. This minus 3 will move to this side. It will become 3x. 3x plus 4y equals 15 plus 28. 15 plus 28 will give you, I think, 43. This is the equation of tangent. Your answer. The question was asking you what is the tangent. Find the tangent. That means equation of tangent. We got this. We got the equation of tangent. How did you do it? Let's revise it. So in the question, what was given to us? 2 points were given. Center was given to us, a comma b, hypothetically was given, and the point of contact was given. Point of contact, POC, was given. I am calling it x comma y. It was given, or x1 comma y1. Okay. Then we first calculated the slope of radius from this. Slope of radius equals what? y2 minus y1, and from this equation it will be y1 minus b. Just remember this one. Okay, it's not tough. The standard formula says y2 minus y1, final y value minus initial y value, over final x value minus initial x value. So what is the final y value? y1 this time, minus what is the final initial x value? Initial y value, b. Then what is the final x value? Final x value is x1. Initial x value is a. So you will get the slope, a number for the radius, mr. Once you get mr, using this mr times mt equals 1 minus 1, you can calculate the slope of tangent, mt value also. Okay, by putting the value here, we got this. You solve it, we'll get a number. Whatever number you got, put it in the equation. From this you will get the value of mt, and once you get mt, you know the equation of a tangent. The equation of tangent is y minus y1 equals m times mt times x minus x. Do we know all the values now? Yes, we have just calculated mt. Put the mt here. Do we know x1 comma y1? Yes, the point of contact itself in the question was x1 comma y1. Put it in the equation, x here and y here. We'll get the final equation. Well, okay, you can leave your answer here also, like this one. I got it here, or you can solve it further like I solved it. This was all about tangent. They will not ask you any question beyond this. We are very close to wrap up this chapter. The next thing is building a circle from scratch. Okay, I will not say they are the concepts, they are more of a questions. Just 2 varieties of question I'll show you. After this, the lecture will be done. In the next class that we will do, I'm gonna do all kinds of questions that can be asked in the examination from whatever we have learned till now. We are almost done with this chapter. You can say we are done with this chapter. All right.